Okay, so this is an alternative way of approaching the problem. So instead of x plus h or f of x plus h minus f of x, wherever we see x into the equation, we are going to plug in our 1. And notice f of 1, we know the value of f of 1 is equal to 2. So I'm going to plug in 2 into the equation. Wherever I see x in the original function, I'm going to plug in 1 plus h. So instead of x squared, it's 1 plus h squared plus 2 times x means 2 times 1 plus h. And at this point, we can simplify. The -1 and the -2 can be combined. And we're going to slowly simplify the equation, expanding our binomial, and of course, combining like terms until we get a situation where we have h squared plus 4h, where we can take a common h out of the numerator that can easily be eliminated with the h in the denominator. So now that we have our first principles in simplified form, we can apply the limit, and wherever you see h, I'm going to substitute that with a 0 because we are talking about as h approaches 0. And right away we get the slope value of 4 at x is equal to 1. So by making that small little change, we have essentially eliminated a step. Now, sometimes in your unit guide, you may see, or unit guide or textbook, you may see this alternate notation for our derivative or first principles formula, which also works where A is the x coordinate of the point of tangency. So this is another way of illustrating our formulas. And because we are working with a function, and don't know if I remember to write the original function of x plus 2, this is just an example where we can rationalize the numerator and use the conjugate. So if the radical is in our numerator root x plus 2 minus 3, then the conjugate would be root x plus 3, which I'm multiplying by both numerator and denominator. This is a skill many of you will have to practice in your unit work and even questions we don't assign to prepare for the test. Now, essentially what happens when you do your binomial expansion, the whole purpose of the conjugate is to eliminate radicals from our numerator. So instead of square root of x plus 2, I will have x plus 2. And the outside inside eliminates each other. So -3 squared, or -3 times +3, would give me -9. So we are able to eliminate and simplify. And once we get to our most simplified form, you'll see that I get a direct slope. The slope of the tangent is 1/6. So this is an important example where it is possible to have a fraction as the slope. 1/6 is the slope of the tangent to f of x is equal to the square root of x plus 2 at x is equal to 7. Now we can take our slope 1/6 and we can take the point we were given when x is equal to 7, y is equal to 3, and instead of plugging it into point slope form, I can plug it into slope intercept form, otherwise known as y is equal to mx plus b. And I can solve for the y-intercept, thereby giving me an equation of the line in y is equal to mx plus b form. So that is fine as well, whatever strategy you are most comfortable using. Now, the questions we really want you to practice involve rational functions. So I have f of x is equal to 2x plus 1. I need to find the derivative at x is equal to 1. Now remember, when I solve for f of x plus h, I need to plug it into both the numerator and the denominator in this situation. So f of x plus h minus f of x, well, this whole fraction 2 times x plus h plus 1 over x plus h is simply my f of x plus h. The blue portion is my original f of x, and I have to make sure, remember to subtract. And then on top of that, I can't forget that I have to divide according to first principles by h. Now I'm going to show you, just like I did yesterday, I have an easier way to write this so we can have our full expanded numerator. So what I'm highlighting in yellow is our full expanded numerator with our common denominators. But instead of saying divided by h and making this look really messy, divided by h is the same as multiplying by 1 over h. Something else you have to remember and practice is that x times x plus h is the common denominator. So when combining our rational equations, we do have to find common denominators. You practice this extensively in MCR, and we are expecting that students did do those units in MCR and are able to combine rational functions. And that's going to require some algebra, some distributive property, being very careful when you're combining like terms. But when you do this correctly, you're often going to get simplified numerator and denominator. In this case, I can cancel out my h's, but notice I've highlighted in yellow that negative. If we forget about the -1, our answer will be incorrect. So when you cancel out your h's, please remember that the -1 remains in the numerator. And now we can apply the limit by substituting 0 in for h. And so you get a final answer of -1 over x plus 0 times x, which simplifies to -1 over x squared. And I'm highlighting the proper notation for my derivative since we started at f of x. F prime of x is equal to 1 over x squared. That's the equation of the tangent line. Now, at x is equal to 1, I need to be able to substitute that point in for x, and I get a final slope of the tangent at x is equal to 1 is equal to -1. And this is a final example of a question in your unit guide, and I just wanted to provide you with step-by-step answers. You'll notice that we have radical binomials in the numerator as well as the denominator, which is going to require rationalizing the denominator primarily, but getting rid of the radicals from the numerator as well. So provided step-by-step solutions that I would like you to review, but I don't think we will have monomial, multiple radicals in terms of monomials on the test, but this is quite a difficult problem.